talking about graphing inequalities in two variables. And for the warm-up, I want you to think about which kind of inequalities have an open circle and which ones have a closed circle, and what do these things mean. And so hopefully we remember that less than or greater than both had an open circle, and less than or equal to and greater than or equal to had a closed circle. And what these mean is that here the number is not included, and here the number is included. And so hopefully that just kind of reminds you of what we've already talked about. Because when we graph these inequalities, we have two situations. We have a closed half plane and an open half plane. And this seems really a lot more complicated than it is. Okay? Basically, a half plane is one side of your line. So you think about when you actually graph a line, it goes through and it cuts the plane in half. And so we've got these two situations, closed half plane, open half plane. I want you to think about it the exact same way that we thought of with circles. We've got a closed dot and an open dot, which means you already know which symbols will give you a closed half plane and an open half plane. And a closed half plane is a solid line. An open half plane is going to be a dotted line. And we have these steps for graphing linear inequalities. And the nice thing about graphing linear inequalities, it's very similar to graphing lines. So you're going to need to remind yourself of slope-intercept form. Remember y equals mx plus b. And remind yourself that the number in front of x is the slope, and the number in front of b is your y-intercept. Hopefully that's something we all already know. And so when we do these, we graph the boundary, which the boundary is just like the line. So we're going to graph the line. We use a solid line when the inequality is less than or equal to or greater than or equal to. We use a dashed line when it's less than or greater than. So remember, if it would be an open circle, we use a dashed line. If it would be a closed circle, we use a solid line. And then we use a test point to determine which half plane should be shaded. I almost always use 0, 0. The only time you can't use 0, 0 is when it's on the line, but you can almost always use 0, 0, and that will help you decide which side to shade on. And then you shade the half plane that contains the solution. So, not really anything too new, because we know how to graph a line, we know how to plug things into an inequality, and then we know how to shade one side of a graph.